Welcome to the Advanced 2 training for today. And let me introduce myself a little bit before we start. So my name is Kuemmel. I'm senior Java developer. Nowadays, most of the time, I'm project manager of some projects running with EclipseStore and MicroStream, especially within the German insurance company Allianz and also the German Frankfurt Airport. They are using MicroStream as, in many different projects as a storage technology. And most of the time, I'm also trainer and conference speaker. Yeah, that's why I'm here. About me. And by the way, the photo is, I would say 5 years ago and 10 kilo less weight, I would say. But yeah, that's just to let you know. Okay, so let's have a short look to the timetable. We started at 5, that's for sure. And it will end around 9 o'clock. It depends a little bit on you. I left enough space for your questions and for your topics that you want to know. Especially the Advanced 2 training is also, there's enough space talking about topics from the previous trainings. Also, if there is anything you want to know and it is normally not part of that training, don't be shy, let me know. I'm able to explain different topics again if this is necessary. Normally we will have a break somewhere between 6:30 and 6:45. Yeah, I will try to fit this best somewhere within the training, to fit best within the topics. Yeah, and that's the point. Let's talk about the topics. So I want to start with the warm-up project, as always. I prepared a small project for you to work along with me. This project is more regarding the advanced 1 topics. So we talked about lazy loading and backup configuration and stuff like that. I think that's the most important points. But yeah, so that means I will share this project with you. There are 2 or 3 different branches in it. And then I give you 20 minutes or 25 minutes to do it by your own, trying out things a little bit. And after that, I will explain that, and you could code along with me to complete that project at the end. Then we go through some advanced topics. I explained some of them already in the Advanced 1 training, for example, the channels, and also the channel migration. But one new topic is the housekeeping itself. I want to explain you what the housekeeping is doing, and there are some special things you have to know regarding that housekeeping, and this is one topic of Advanced 2. I also want to talk again the exception handling, and especially handling of EclipseStore with Docker and Kubernetes. Regarding transactions and rollbacks, shutdown on error, gracefully shutdown is just a small topic, and I think it's a small topic, but an important one. And that brings me to the main topic for today is the concurrency handling. So it's always an interesting topic. It's not only a topic regarding EclipseStore or MicroStream. It's an all-over topic that everyone has to know how to handle concurrencies. And it's a little bit different on EclipseStore. That's why we have to talk about this. Then there are another 3 topics. Let's call it customizing. There are possibilities to customize EclipseStore. There are different customizers there. Let's say the custom type handler, the custom legacy type handler. But I have to switch this. This is not the right one. But we also have to talk about the custom storing behavior. This is also possible to change that. And last but not least, around 1 hour, I guess, we talk about the MicroStream cluster. We talk about data replication, on-premise platform solution, and so on. So there are many things you need to know about the cluster and the replication we provide and so on. Okay, so, and after that, I already mentioned that question and answers, this is all the time part of the training. So regarding the material, the sessions are recorded, so you will get access to the recordings afterwards, and you will also get access to the code repositories of all demo projects which are part of that training. I already mentioned that ask as many questions as you can. I try to answer all of your questions. And this is the important part, some links. And let me share that links directly now with you. So just a second. So I already prepared that. So too many windows. So here we are. Yeah. Okay. These are all the links you need to have. Okay, here are the links, and I will share you every link on the different topic to the special project. And yeah, you could open these projects with any IDE of your choice. It could be IntelliJ or Eclipse. It's totally up to you. But let me explain this a little bit later. Regarding the certificate, you will get one around 5 or 6 days after the training, and you could find the certificate when you join the http cloud.microstream.one. This is our cluster or cloud platform. Just register there, and as I said, after 5 or 6 days, when you click on the certificate section, you will see a certificate for you. But the important thing is you have to register with the same email address you joined here at the training. If you need to use a different one, just let me know your email address now. Then I could take it and store it, and then I will add the certificate with that specific email address if you want. Okay, so let's move on. Yeah, let's start with MicroStream and EclipseStore, and let me just summarize the framework itself a little bit. So, and I already said, okay, it's a Java framework, basically. It's from scratch invented object graph serialization. That means it's our own invented object serialization. It's not the Java one. And it serialized the data to most known systems, especially file system, AWS S3, Kafka, relational databases are possible, DynamoDB, Redis, Azure, and many more. And the special thing is that we are able to update the serialized data on the storage partially. That means you don't have to serialize your object graph again completely all the time. It is possible to doing small changes, and you only have to serialize the smaller parts. The idea is keeping most of the data in memory, expect the lazy parts of the graph, and there is no data mapping anymore. So you could choose your normal Java object model, your normal Java POJOs at the end. No annotations needed, and that's it. So, and it works like this. But we will see that within the training then. The idea is just having data within the RAM as in-memory data, and you need someone to create snapshots at the end. And yeah, you don't have to take care about that. EclipseStore did this for you, or will do this for you to do the synchronization between RAM and the persistent part on your hard disk. Okay,
Sorry, Christian. What do you mean by taking snapshots? I thought that the whole idea was to have the data in memory to be processed as fast as possible. So why take snapshots?
So you always need a persistent at the end. So when your machine goes down, you need a persistent part at the end. So on startup, you need the data back again, right? So this is why
Okay, I
we need
understand.
to
Okay.
store the data. So that's when I talk about snapshots, I mean when you change something within the RAM, you have to call a method which is called a store. And whenever you call the store method, that handover part of the object to that store method will be snapshot to the hard disk. So this is, yeah, it's kind of like a store or insert or update statement within any other database. And that is what I said. This is what a snapshot is.
And the purpose is to be able to retrieve it later in the future much quicker, if necessary.
Yeah, especially when the machine is not available for a short term, or when the machine goes down, the data should be stored somewhere. So it's a persistent storage at the end. EclipseStore is not only an in-memory storage or database, I would say. It's also it always has a persistent part somewhere. It could be AWS S3 Bucket, or it could be on your hard disk, persistent volume, whatever. But there is a persistent part comes with EclipseStore at the end.
Understood. Thank you.
Okay. So let's move on to the first example. But first, there are some people that's already joining. Just a second. Okay, so let me share the demo project with you. So where we are. Yes, here it is. So good. So this is the URL to the example project. Just check it out if you want to code along with me, and if you want to try it out. So I will also go to my IDE, and I already checked it out. The project itself should look like this. You should stay in the main branch. This is the starting branch I would recommend. So let me just double check if this is the right one. Switch to, yes, there are two branches. One is the main branch. This is the branch where we can start the project itself, or the warm-up example. And the implementation is done as the completely finished project. And this could also be an interesting demo for you, just to have a short look, how does it work. Okay, so warm-up. Let me just explain the example a little bit. Therefore, I have to move to the presentation back. Okay, this is the exercise. We checked out the MicroStream Training Bookstore warm-up project. Start at the branch main, and you have to complete the following classes. There is a storage class. For the storage itself, the storage.db class should be completed. You have to initialize the storage manager. The controller class is already there, which is called book controller. And you should use the builder pattern to initialize the storage manager. We already did this in the advanced one and in the fundamentals training. Just set up the channel count of 2. The name of the storage target should be data. We also need a backup target, which is called backup somewhere. You should set the lazy clearance to 10 minutes. If you never heard that, what lazy means, I will clarify this after or during the example or during the exercise. And we want to have an index of for books. And the first 2 digits of the ISBN should be the index. And we need a lazy behavior at the end. So we need lazy elements within that structure. And we always need a full list of authors, even when the last book of a specific author is sold with lazy behavior. So this is the exercise. Just take your time to read all this. I will explain this to you within the project again. So there's nothing really special in it. So the initialization, really straightforward, I would say. The special thing is maybe the lazy clearance to 10 minutes. That could be interesting. The index maybe could be challenging, I would say. But this is also an example from the advanced 1 or 2 training. There is an example which shows that. Okay, so let's jump in. Let me explain that within the IDE. So this is the project itself. There is a structure already available, so let's go through it. There is one DB class which is empty. So here the initialization of the storage should be, you should use the builder pattern doing the initialization. Then we have one root object. This root object is also empty. This is the place where the authors and the books should be with that indexing stuff. And the book and the author object is already completed. So these are the Pojo classes. And then we have the book controller itself. And it is marked, enter your code here. 1, 2, 3, 4 controller methods within the exercise. Okay, so I would give you, let's say, 10 or 15 minutes. Is that okay? Just to try it out, to fill some classes with code. And after that, we go through that together. And I will explain everything again, just to bring you all of you, just to bring you at one level, so of understanding how EclipseStore works. So if there are any questions, feel free to ask. I would recommend to start with the DB class. This is the class where the initialization happen of the storage manager. And I always have to explain, we are within a Micronaut project, and the way we initialize EclipseStore here is not the recommended way doing that within a Micronaut project. But I have to keep it as simple as possible, and I just use Micronaut to, having those controller classes to calling REST endpoints to see the result at the end. So, but yeah, it's not the recommended way doing that within Micronaut. Yeah, exactly, Frank. Each store method is a synchronous method. It's a blocking method. So the first two objects that we need are these two. So we need one instance of the storage manager itself. So it's kind of like the DMS, the database management system, I would call it. Most of all the actions are provided by the storage manager. And we need one instance of the root object. And in that case, the root object is the entrance object to the object graph. We always need that root object because based on that, we hand over later on, we hand over that root object to the storage manager, and based on that, the storage manager knows what classes are part of the object graph itself, because everything, all the sub-objects below the root object itself are handled by the storage manager. And we also need this root object for doing stream or streaming through your object graph and calling all the collections within your graph. So the root is the entrance point, I would say. So to initialize the storage manager, I use a simple static method here. And as I explained, we will use the builder pattern. So, and in that case, I use the embedded storage manager or the embedded storage configuration. And that configuration or this object provides me the builder itself. And with that builder pattern or with that builder object, I will be able to set channel count, for example, of 2. Channel count, it's an interesting topic. It enables you to write down data to your storage itself in a multi-threaded way. So that means the channel count has to be always a power of 2. So that means we could have 1 channel, 2, 4, 8, and so on. And yeah, I will go into that a little bit deeper later on. Set channel count, the storage directory, set storage directory. Let's call it data. Another one, set backup directory, backup. Yeah, that's all the configurations that we need to do. Based on that, we create the storage foundation. Oh, sorry. Create storage foundation. Based on the foundation, we create the storage manager. And here on that part, we can directly hand over the root object. And we need to call the start method. This is an important call that enables the storage manager to start the storage. And especially at this time, the storage manager goes to the persistence and loads all the data from the persistence except the lazy parts. And this happens all the time on server startup. So it loads all the data to the RAM except the lazy parts. Okay, lazy parts. That brings me to the lazy reference manager and the next point, how to change the default lazy clearance behavior, I would say. So that means when you load lazy parts from the storage, then they are going to the RAM and they will stay within the RAM till a specific time, I would say. And the default time value is 30 minutes. That means when these objects stays untouched for 30 minutes, they will be cleared at the end. And there is another indicator to clear the references is when we reach a memory quota of 75%. That's the default behavior. So whenever we reach 75% of the memory, then the lazy clearance will clear the oldest or the oldest entries of some lazy stuff. And we are able to change that behavior. And for that, we call the lazy reference manager .set. And we use the lazy reference manager again. Let's call a new one. So here, come on, where is it? So, okay. So we use lazy checker, and this checker needs a duration of minutes. So let's do it like this. So let's say duration dot of minutes. Let's say 10. So that means after an object stays untouched for 10 minutes, this will be cleared at the end. So let's call 2 millis, because we have to provide that value with milliseconds. And at the end, we are able to call .start. So did I forget something? Oh, there's one bracket which is missing. Okay, that's it. So that means the important information is that we need to do that lazy reference manage check before the initialization of the storage itself. That's important. It's also part of the documentation. So it always needs to be before. Otherwise, you will get an exception. And we are good to go for this part of the initialization. So that's it. Nothing more has to be done within a DB class. So next step is the root object. So it's empty. So we talked about what we basically need. So we need a collection for books, which should be indexed and lazy. And we need a collection of authors. And I will explain this to you a little bit later. So then this will be quite clear. So let's first start with the books. So we need an index based on the first 2 digits of the ISBN. And for that, let's create a private final map. So that's what we need. We use a string at the beginning, and I already said this, we need lazy. So we want to have the lists, or we do not want to have all the books within the memory. That means on the value side, we need a lazy list of books. This is what we need. Let's call it books. And now let's create a new hash map here. That's all we need. Okay, so each book has its own author object in here. You could see that here. But this is what I already explained. So, and this is also the hint of the description of the exercise, that when we delete a specific book, which is the last one of a specific author, so we will lose also this author within the database. So that means we need a separated list of authors somewhere to fill combo boxes and stuff like that. And that's why we just create an additional map of authors, and I will copy this straight from GitHub, and we do it the same way. So that means we have a string and a lazy author, and this is a little bit different to the books itself. So and in that case, yeah, I did that because I just want to show you this is possible. This makes sense doing that in this way, especially when we want to keep the values or the objects within the memory as low as possible. And in my opinion, this structure is one of the best structure, especially when you want to when you having millions of data within one collection. You could add some indexes here, let's say just the important values of the author, let's say email address or stuff you want to search for, and then you will get the specific author directly from the map. So that prevents you by loading all the authors by streaming through the map itself. And I think it's the same here with the first 2 letters of the ISBN. So that enables us to search for a specific range of ISBNs and not loading all the list of books at once. Then this is what EclipseStore did at the end. It's an in-memory database. And to stream through a list of books to find a specific one, we have to load the whole list at once. And this is what we don't want at the end. So therefore, a map is a great opportunity to handle it this way, and that's why we're doing that. So we need get and set methods. So let's create some. That's it. Any questions so far? So we created or we initialized EclipseStore within the DB class. There are many different ways for initialization. This is one example. There are many different ones, especially when you use the Micronaut integration or the Spring integration, whatever. Initialization is totally different, but this is the easiest one, just to give you an idea what is needed to initialize. So channel count, storage directory, stuff like that. That's the most important ones. And this is always makes sense, having a specific configuration of lazy clearance. Most of the time, I would say 30 minutes are okay, but in some cases, it makes sense to have a lower configurations, and that helps you. Then this is regarding the data structure. This is also, all of you are used to use normal collections like lists and sets and so on. But especially with EclipseStore, it makes totally sense using maps also as collections. And I would say they are more important than normal collections and more useful, I would say. Okay, that's it. So a book and author are already filled. So then let's move on to the book controller class and start with the controller content. Okay, a lot of things has to be done there. Setup data. So that means, oh, this is a different one, isn't it? Create books. That differs a little bit. Am I wrong? Load mockup data. No, just the names are different. Okay, so of course we have to load some lists, and for that I created these mockup utils. That is not interesting for an example itself. So as you can see it here, there are some JSON files with some books in it. I guess there are around thousands of books, and authors are the same. I load all the data, so the load mockup data loads all the data, creates objects, and returns a list of books at the end. Just need to okay, so let's stream through these books. So let's say all created books dot for each, and now we have to store them. And the business logic of that is not the easiest one, but let me explain that. Okay, we stream through all the created books, and now let's add them. So let's call db.root. So I already explained that the root is the entrance point to our graph. Then we need to go to the get books collection, and then we call the method compute if absent. So that means if there is a specific key, which is b.getISBN, b is the book itself, get ISBN, and especially of the ISBN.substring, give me the first two letters. So if there is no key with that two letters, then create a new one. And this is made by, oh, sorry, there is something missing, 0.2. This is the right one. And if there is no, just return lazy.reference with a new array list in it. And so we do need a type in it, that's okay. So, and after that, we call .get. .add, and we need to add b. Okay, here we are. So there is one, we need one here, right? So yes. Okay, let me just explain this a little bit. So again, compute if absent, that means do this search for a key, which is the substring of the ISBN of the first 2 digits. And if there is no one in it, just return a new lazy reference of an empty array list and add this array list and return it. And after that, we could call a get to get this array list or to get the specific one we want to use. And then we add the book itself. That's it. So this is, we have to do it this way because of the hash map. And then we need another one. So because it's the same with the author itself. And this is what I just want to copy, makes it a little bit easier. It's the same on the authors. So get authors, compute if absent. So if it's there or not, search for the author, get ID, the email address, and the last name. That's the index I created that enables me to search within the key to find a specific one. And it's just an example, just to give you an idea how this could work. So you could do 1,000 different things within the key. That's totally up to you. This is just an example. And return the lazy reference at the end. And lazy reference. And if not, create it with b.getAuthor. So just create a new author object at the end. And that's it for the creation itself. But now we forgot to store that things. We added something. That means here we need a db.storage manager. So we need access to the database management system, and we have to call the store method. And in our case, I use the store all because I want to store multiple objects at the end. And I want to store the authors, root.getAuthors, and I want to store the books itself, db.root.getBooks. Okay, here we are. That's all we need. So why do we store the collections itself? Within EclipseStore or MicroStream, you always have to store the reference holder. So that means in our case, we added elements to the collection itself. That means the collection itself is the reference holder of the objects. And therefore, we changed the collection. So because we added something, and I think that's one of the most important rules within EclipseStore. You always have to change, you always have to store the reference holder itself or the object which has changed. So this is that's really important to remember that. Otherwise, it will not work. So. Okay, so create books, that's it. Let's move on, create a single one. And the code is mostly the same. So that's why I copy this from the GitHub page here, because the code is mostly the same. Compute if absent, we already talked about that with the substring, lazy reference, and so on. It's the same. We're not adding multiple elements, we are adding just a single one, and that's okay. So this is how it works. So let's find a specific book that starts with 1. So let's do this. So let's create a stream, db.root.getBooks. And we have to stream through the entry set of that map.stream. And now that enables us to call the filter method. And we say, okay, for each s.getKey starts with 1 or especially this one because it's a string. And after that, I have to call .flatMap because I want to go through all the books of a value. So that means e dot get value. That brings me the lazy reference of the books. And to load the books itself, I need to call the get method. So as I said, this statement brings me to the lazy element. It returns the, let me just double check, get value. You see that it brings me a lazy list of book collection. And after calling the get method, the data will be loaded to the RAM. I need a stream here. Oh, not here. Dot stream. Come on, what's wrong? So dot stream. Now, stream, and at the end I need a collect with a collector, collectors.toList. And that's it. Okay, let's format this a little bit for better understanding. Flat map. So this, let me see. Oh, no. So, yeah. And we need a return at the end, of course. We need a list of books. Okay, last but not least, there is the last method, the update multi-books. And I want to keep it simple at the beginning, without any rollback mechanism and so on. That's why I just use the first part of the method. So I use I want to update all the books that starts with 1. It's the method above here. And let's do it like this. So we do not need this for now. So I stream through all the books and I change the price, or I set the price to big decimal 50. And at the end, we need to store it. But now we have a problem, right? So we do not know which item has to be stored. Or do we? So we could do it this way: db.storagemanager.store. And so in that case, we could call the store all method. So we could use this one. And that gives us the possibility doing it this way. So that means we knew that we change every object within that collection. So for each object, or on every object, we set 50 euros or whatever. So that means there is no object which stays unchanged within that collection. And that brings us to a situation where we could call the store all method. And you have to be careful because the store all method are available in 2 different versions, I would say. One is, just a second, one is the store all with an iterable in it. That means that store all method will only store or will store all the elements of the iterable at the end. So that's exactly what we need in that situation here. But there is another one, store all method, and this store all method stores the multiple objects which are handovered at the end. This is the situation what we do up here. So here we use the store all and we hand over 2 different objects. That means if we changed something within the authors here, so let's say we changed something or we changed a specific author at the end, this will not be stored because we using the the lazy storer in that case. This is the default behavior. It only the object directly handover will be stored. It's the same in that situation here. Only the elements of that collection will be stored, but not the sub-elements of that items within the collection itself. So therefore, you have to be careful which store all method you should use. And for now, this is okay using it this way. Is there a different way we could store elements? Any ideas from your side? I would say this solution would be an okay one, so you could use this. There is another one which is not a recommended one, but maybe for you it's a good solution. So you could do it this way: db.storemanager.store, and let's call b. This is also possible, even if it is not the recommended way. But why is it not recommended? So we talked about this within the chat. So this is exactly because the store is a blocking operation. That means it will slow down your iteration a lot. So, and this is why this is not recommended. Doing this way will work much faster than having the store within the iteration itself. Okay, so it's possible, and it is working, but not recommended. And there is, last but not least, there is one solution which is provided by GitHub. So the GitHub solution. So that means on the other branch, we create our own store. And I did this because just to repeat that topic, that we are able to create specific store. Just to remind you on that, you will be able to create a lazy store, and this is, as I already explained, the default behavior when you especially, let's do it again, db store b in that case. So that means in that case only b will be stored, but no sub-object of b. Let's imagine you change the author within b. It will not be stored at the end because it's a lazy store. It stores only the first level of an object or the direct element which is handovered. In that case, it's b. But there is a possibility to create an eager store. So let's do this just to remind you on that. Create eager store, and this store will create a store that stores everything below an handover object. Let's call it ES for eager store. And in that, when you use an eager store, all the sub-entities of a handover object will be stored also. That could be very useful, but I would always recommend to use the lazy store instead of the eager store, because in some situation the eager store could lead to a huge amount of data on your hard disk. Let's imagine, based on the fact that EclipseStore is an appended storage. That means every store that you call appends the elements at the end to the end of the storage. And that means when, for example, when we would call create eager store root, for example, then the whole root object with all its sub elements will be attached to the end of the storage. And yeah, you could imagine this will lead to an really huge amount of memory usage at the end. And yeah, it's not the way to do, I would say. at the end, this will be cleaned up by the housekeeping process. That's for sure. But for now, we should prevent that. So, but just to explain you, there is a lazy storer and an eager storer. And in our example, we only need the lazy storer. And we use the lazy storer here to say ls.store. And that gives us the possibility to mark or to add the object B to the storer itself. That means the lazy storer ls knows, okay, B is marked for storing. And at the end, we could call ls.commit. That stores the data directly to the hard disk. That gives you kind of like a transactional behavior at the end. So that enables you to use try-catch mechanisms to create a rollback scenario and so on. But we will talk about this a little bit later. This is a topic for later. But these are, I would say, the three different possibilities to store these mechanisms or to store these changes here. We could use the store all. In that case, this will work totally fine. But doing it in a more advanced way, this will also work. That's it. Yeah. Any questions so far? Sometimes that's a little bit confusing, what to store, when to store, and the different mechanisms. But I think the message is storing, it's always important. Storing the object which has changed. In case of adding something, you always have to store the collection, because the collection itself is the reference holder. And in case of changing something within a book, for example, you have to store the book. That's it. Okay, so let me check if everything is okay. To try it out, I would recommend switching to the next branch, and I will do the same. So in case of, live programming is always quite a mess. So that means, let me just switch to the branch, which I believe it is working. So let's move on to implementation done. So let me discard everything. Here we are. And you see the method is much bigger than we do it, but let's talk about this a little bit later. And you also might think, okay, why is only get methods are used? This is also on purpose, because it enables you to call these methods within your browser to try it out if this is working as expected. So, okay, so that's it. Let's do a Maven update first, because there might some changes. Okay. And one special hint I have to add is whenever you want to start a Micronaut application within your IDE, you have to ensure that the annotation processing is enabled. In my case, or also in your case, you will find that we are the preferences and on the Maven section. And there is one part which is called annotation processing. And in my case, the experimental and also the automatically version will work. So it's important that annotation processing is enabled, and it's the same on IntelliJ. So I do not know the exact position where the annotation processing could be enabled at IntelliJ. Maybe some of you could write this down to the chat. But that's important. Without the annotation processing, that application will not start at the end. So you have to enable that. And after that, just visit the application class here, which is already in place. Right-click, run as Java application. And at the end, it should look like this. You should see that Micronaut is up and running. And now we are able to call the localhost 8080. Let's call the setup data, create single. Yeah, we could use the ISBN starts with 1. That should show us some data. Let's try it out. Okay. Did I miss something? 8080 localhost. So I have a page not found. Did I forget something? Yes, I forget the books. Okay. /books/ Give me just a second, then I will share this with you. Okay, here we are. This is how it looks like on my side. So I call the localhost 8080 /books/ISBN starts with an A. And this is that endpoint here. And as you could see down here in the console, you see there is something happened with the lazy reference manager. So I have to double check this. Maybe there is an already existing database already there. Let me just a second refresh. Okay, so let me delete this. Okay. Let's start again. Refresh. Okay, something is happening. Lazy reference manager instance only exists fail. Okay. Okay, this is initialized. Let's try to create some books. Maybe it's because it's empty. So let's call setup data. Book successfully created. So, and here we have our books. So I have to double check why these errors came up, but maybe because I upgraded the version to 1.3.2 before the training. But yeah, it looks like this. And let me just check if the data is there when we restart the application. So. Oh, host. So localhost 8080 books starts with an A. Yes, it works. So you see that I restarted the application and the data is still there. Yeah, it works as expected, but I have to double check what is going on with that message here. Maybe it's just a warning, but yeah, I want to check this for you. Let me take a note. Okay, so does it work on your side? Okay, thank you, Alexander, for IntelliJ. I think it's the settings build compiler, and somewhere yeah, you could see it here, annotation processor, and you have to enable the processing here. That makes totally sense. And then this should also work on IntelliJ at the end. Does it work on your side? And by the way, did you get the same warning message in the console? It is working anyway, but yeah, as I said, I have to check this. I can give you 5 more minutes. Take your time. If you want to try it out, do this. We have enough time. If there are any questions on your side, especially maybe you tried out EclipseStore before because you're at the Advanced 2 training. Some of you are already visited the fundamentals and the Advanced. Maybe you tried something out. Feel free to ask questions regarding your experiences with EclipseStore. It did not create a backup folder? Ah, okay, that could be in my case, the 2 folders are created directly within my project itself. On the right side, you see that here. It depends a little bit on your application structure. In my case, this is working. Let me just double check the DB class for you. So this is how it looks like on my DB class. You have to add the line set backup directory. Can you check if there is, or did you use the same branch like I do? In maybe that could be. Maybe there is no. It's set backup directory should also be there. Okay, and it's not created. No idea why is that. Ah, okay, great. Okay, so regarding that backup folder, just let you know, for those of you who not visited the fundamentals or the advanced one, this is one backup solution. I call it the mirror backup, and every time you call a store method, the store goes to the main storage. This is the data folder. But after that, there is an async call to the backup folder and stores the data in the same way. So that means the backup folder at the end is always a copy of the data folder. If something went wrong, maybe you disconnected from your persistent volume or whatever, you will lose the last call, the last store call, but it enables you to copy the stuff from the backup directory directly to your data directory. And based on that, I always recommend to write the backup to a different system, of course. In some parts, it's totally enough to use a second persistent volume. That makes sense sometimes to write the backup to a second persistent volume, especially when you use Docker or Kubernetes. And there is a third opportunity doing, or a second opportunity doing backups. You could write a full backup at any time. And most of the time, we recommend having a second persistent volume for the mirror, and then writing the full backup once a day or once a week to an AWS S3 bucket or whatever else. So it's totally up to you. And that enables you having most data always backupped and many different instances to recover your data. And this is the only way doing that. We will talk about that later, a little later, but it's strongly recommended using the backup functionality, the embedded backup functionality of EclipseStore. But for later topics. Any questions? So far. Okay, let me just check the topics for not forget something. Okay, we talked, we could add a check mark. One more project, check. Let's talk about the channels and housekeeping and stuff like that. Here we are. So in that case, we used channel count of 2, and there is a presentation that is created. Moment. So there we are. Something went wrong with my mouse. So just a second. Where is it? Here we are. Okay. So you see that whenever I move within the presentation, now here it is working. Okay, so let me skip this storage channels. When we talk about the I/O threads of EclipseStore, then we talking about storage channels, and yeah, as I already explained, it must be power of 2. So that means you could have 1, 2, 4, or 8 channels or some more. When should you use channels? In that case, when you have a lot of lazy loadings, that means you have a lot of data which stays on the hard disk and has to be loaded the lazy way. Or when you have let's call it unusual high amount of inserts. So let's say you have you have a system that writes logs somewhere from machines or whatever, then it could make sense having multiple channels. And of course, when you want to store a lot of binary files, images, or document, that makes sense because that enables you storing in a better and performant way. Most of the time, we are good having something between 1 and 4 channels. So, and this is what we basically recommend. If you have a lot of write requests and storing data to a remote source, for example, then 2 or 4 channel makes sense, especially when you use AWS, for example, or a remote binary storage as primary storage, then it makes sense having multiple channels because that enables you to storing data in multiple threads. That will increase the performance enormous. Something between 1 to 4 is totally enough. For now, we would not recommend more than 8 or 16 because of data segmentation. The more channels you have, the more the data will be segmented into different parts. And when you access it, you always have to collect it from all these segments. And that normally makes not really sense. There might be some special use cases having more than 4, but this is totally up to you. And therefore, we always recommend test it. You have to test this, but this looks not as it should look like. So, okay, and you should test your application with different setups. Give it a try, and which fits best for you, you could use at the end. Some people always might ask, okay, is there a way to migrate from 1 or 2 to 4 channels, for example? And let's say, till 2 months ago, we invented a possibility to migrate. Now this is possible. Because it cannot be changed the easy way. So you will not be able to say, okay, now we started with 1 channel and then you switch the configuration to 2. This will not work. You have to migrate the storage at the end. And since version 8 of MicroStream, this will work with a specific dependency. And I will share this with you in a project. And there is, I would recommend doing this way, and it looks like this. So let's just go through for a short moment. there is one storage configuration up here. This is the source configuration, and this is what the storage looks like, the old one looks like. So we have 2 channel count, and we get the configuration, and here's the target configuration. And there is one object which is called the storage converter, and the storage converter converts the storage to a different format, and in that specific case, the channel count. I provided you an example project also, having that, and we could also test this. Channel migration is the name. Let me share the link to that project. Okay, so it goes to everyone. Here is the link. Just check it out if you want. I already did that. Let me close the old project. It's no longer needed for now. So channel migration, it's also a Micronaut project, nothing special in it. All the classes are already there. And now you could see this is the DB class, and I started with channel count 2. There is no storage for now. So that now let me start that. Let's call the, let me just double check if there is, yeah, setup data. It's the same. So let's call localhost 8080 books and then setup data. You see, Micronaut is, or MicroStream and EclipseStore is starting. Let's call the ISBN. Is there a, yeah, starts ISBN 1. You see, as the data is here, it is created, and we see that when we refresh the project, we see this is the storage folder, and it consists of 2 channels. Now we could close the project, and we stop the project. And there is one main class down here, which is below the DB class, and it is called main migrate channels. And this is the exact functionality of what I shared with you within the PowerPoint presentation. It's the source configuration, the target configuration, and there is one storage converter here, and it converts it from source to target. There is an upcoming, in one of the upcoming versions, that storage converter is more powerful than this one, which is now available. But yeah, you have to wait for documentation. It's an upcoming version doing more stuff or converting more stuff at the end. Yeah, at the end, the data is distributed through the different channels. So let's try it out. Let's start this main method, run as Java application. You see that storage conversion finished. When we now refresh the storage itself, so we will see now the data is distributed to the other channels here, and it worked automatically. You do not have to take care about it. So it's totally automated. So due to the fact that EclipseStore is a pending storage, so most of the time people thought, okay, it's kind of like we having a tree on the binary side. This is not exactly the case. The storage it's a different serialization, and it's on the hard disk. It's not a tree. It's kind of like kind of like a key value storage, I would say, and that makes it easier to distribute the data at the end to different channels. But yeah, it is handled automatically. Okay, any questions so far? Just a small topic, but it's interesting that you have to know this in case of you want to change the channels to improve the performance. later on. So when data is growing more and more, then it could make sense having more channels at the end. Maybe that is a good solution for you. Okay, so this was the topic regarding the channels and the channel migration. And I got last one topic more for before the short break. So let's close it all. And it is the housekeeping or garbage collecting, whatever else. Let's jump back to the presentation. Where we are here. Yeah, this was okay. Housekeeping. As I already explained, changed and insert data will be appended to the end of the binary files. This is also the case when we doing updates. So let's say there is one object within the storage. It's a customer, and the customer has the name, let's say Max or whatever. When you change the name, the same customer will be appended to the end of the storage itself. And then we change another name and another. All that happened on the same object. At the end, we will have multiple objects of the same type within the storage. And that's the reason why we need, we call it housekeeping. And the housekeeping takes care about cleaning all that duplicate entries within the storage. And part of that housekeeping is also, which is called a kind of like a garbage collection. And that garbage collection deletes all the deleted stuff at the end. That means when you, for example, when let's imagine we have a small collection which consists of 5 customers. It's part of the storage itself. And what happens if we delete, if we remove one customer, and then we have to store the collection itself, right? So because the object which has changed is the collection itself. When we call the store method on that collection, not the whole collection itself will be attached to the end of the storage, but a part of that collection will be stored at the end. But the original collection stays within the storage itself, and therefore we need the garbage collection. And it's in some parts it's the same like the housekeeping. The housekeeping consists on cleaning stuff and keeping the storage in an acceptable size, and the garbage collector collects all that things which is deleted within the storage itself. Yeah, this is an additional and more advanced explanation. This is how the objects look like within the storage. There is always an object ID, and in that case, the object ID is the same. This is what I explained. And normally there is another information within. It's the object type ID. Yeah, but this is not important for now. There are 2 important values. The housekeeping interval means it's it's the how to explain. It's not the time budget. It's the amount so I don't know how to explain that in English now. Sorry, but yeah, it's the time between the housekeeping is running. So, and it's the same for the time budget. This is the budget which can be used for the housekeeping. And the housekeeping is working in a little bit different as you might think, because some of our users always think, okay, housekeeping is running, and it deletes during that 10 milliseconds. What it really do is it marks things as to delete it. So that means the housekeeping is running and running, let's say every second for 10 milliseconds, and within that 10 milliseconds, it marks elements within the storage. And sometimes it goes through the whole storage. So that means it finishes the process of marking things, and then the garbage collector comes and cleans those things. That means within that 10 milliseconds, it's only marking. And that's why some of our users are wondering and tells us, okay, we see that housekeeping is running, but the size of the storage is not decreasing. And this is the explanation. So housekeeping marks things, and the garbage collection comes and deletes things within the storage. And in some parts, it makes sense to increase this interval and also the time budget. And that's why I want to show you this. Let's jump into an example project. Okay, general migration, we already talked about that, so we do not longer need this. It is part of the configuration, right? MicroStream configuration. Let me just check. Yes, it is. 1 second. I will also share this with you. There is one project which is called MicroStream configuration. It is normally part of the fundamentals training, but it contains a specific branch just to visualize that housekeeping stuff. And therefore, the branch name is MicroStream configuration housekeeping example. And there is one controller class in it. And you see that it's an interface which creates an in stream, 10 streams, and it creates books in a really high frequent way. So you remember these mockup classes here with books, there are around thousands in it. And what I do here is I create a stream, and it for each that book, and it creates, yeah, in that case, 10,000 books. And there is a configuration with the default values of the housekeeping. And when we start this, we will see what happened on your hard disk. Let's give it a try. So let's start the application, and you will see what happens. So configuration, I need to extend this. Let me refresh it. Okay, so application. So let's start this, run that. Oh, okay, just a second. I need a Maven update. Okay, it should work. Okay, now it looks different. So on my other monitor, I will start the creation. It is called create books. So books/create. Okay, then we have to be fast. So localhost 8080 books create. Okay, it's running. So let's call refresh here. Oh, come on. So data show in System Explorer. Hopefully we are fast enough. No, we are not. Where is my, no worries. So where is my, oh, that's not right. I can find my Explorer. It's somewhere on my 3 monitors, but I'm not sure. No, it's not here. Here we are. So what we see here, let's jump into the data folder. And then you see this, you see all that different channels files, and I will create those books again. So books/create. And now you see what happened on a storage side. You see this? The storage on the hard disk increases again and again and again. And the housekeeping doesn't have any chance or any chances to decrease the amount of data which is stored to the storage itself. You see that this is around 4 and so on, and the storage is growing again and again and again. And this is what happened when you store data in a high frequent way. And you also see that slows down the database. So we have to change something here. Okay, books are created. Now we created around, I don't know, 10,000 or 20,000, whatever. Let's keep this. Let's delete the storage. Yeah, let's delete this. That makes sense. And now we could change the behavior. So let's increase the interval and also the time budget. And then you will see the differences at the end. So we're doing the same. So we running this as a Java application. And let's call the books create again. Let's call the refresh. Show in System Explorer. Data. And now you see the differences, right? So it cleans up the channel files much better than before, because the housekeeping process has much more time to handle those incoming data. So let's click again on create, and you see it is managed automatically. And sometimes it is necessary to handle that this way, to increase the housekeeping. It makes more sense to have this way to prevent the growing memory on your hard disk. Okay, any questions? Housekeeping. So always good to know how to handle that. Storage channel we already talked about. Housekeeping. So this is the way how to set it. You will also be able to set the housekeeping interval with the builder pattern. And yeah, I think that's important to know how this is working. Let's move on. Okay, I skipped one topic before the break. This was the Kubernetes thing and best practices and so on, but no worry, we will come to that a little bit later. I want to directly start with the main topic for today. It's the concurrency handling. Some of you might already mention that it's important to keep in mind that concurrency is, especially with EclipseStore, is important. And I want to explain you why that is. I prepared a presentation for you. So let's start with that. And I also want to share the project with you. There is one project which is available within my GitHub. And this project contains many, many different branches with different solutions. And I added, yeah, kind of like a step-by-step best practices how to handle concurrency. But first, we have to clarify why it is sometimes not that different to any other databases, but EclipseStore is a little bit different in some ways. Okay, so we have to talk about different layers of concurrency. That's important because there are some different layers. And we have to clarify the question what exact concurrency we have to deal with compared to MySQL or any other relational database. It doesn't matter to EclipseStore. We have to clarify if EclipseStore itself is responsible to take care about concurrency. And then I want to give you some advices, possible steps to solve concurrencies and so on. let's look at this. So I think this is a good example of concurrency handling. And in that specific case, we could easily reproduce this behavior within the project I shared with you. So let's jump in. So I already opened it. So I have it here. Where is it? Concurrency. So let's open this project. Let's do a refresh. Okay, let's jump into the controller class. Okay, so what we do now is we create some books within a storage, a DB class, and so on. Everything is the same we worked before. And there is one method which is called iterate. So that means there is a while into, and we iterate through a collection all the time and all the time. And during that, we calling the delete book method. At the same time, we running through that. And let's see what happened at the end. So let's start it. Maybe I have to do a Maven update first, just to be sure everything is working as expected. So yeah, run this Java application. So first we have to initialize the storage itself. I will do this on my second screen. Books create, right? This was the, yeah. Books are successfully created. Now I call the iterate. So let you see that books create, and then I say books.iterate. Iterate. So now you see the application is iterating through the books. You could see that in the console down here. And now let's try to delete. What is the, just to be sure we're calling the right, delete random. No, delete book. Okay, this is the right method. Let's make it. So here we are. And sorry, delete book. So now this is what we want to see. This is the exact exception we want to have, the concurrent modification exception. And this is the reason why we need to deal with concurrency, because, and why is that? The reason for this is that all the different threads on an application are working on one object model, right? So this is the main difference to any other database which contains database copies all the time. When you access a MySQL database, for example, you request some data from that database, and at the end you will get the data and you will load the data. And if 10 people doing that, they will get copies at the end of a copy of the data for their session. With this method has some advantages and also disadvantages. EclipseStore, because it's an in-memory database, works like all the people and all the threads are working on one object model. And yeah, that's the situation, I would say. Also with some advantages, because when you always need to have copies, that increases the amount of RAM which is used on your application server side, right? So, and that's different to EclipseStore. We are working on one object graph. That means we only have one object graph within the memory, and but we have to deal with concurrency. Let's switch back to the presentation. So we see that, and now we have to talk about different types of concurrency. When we talk about concurrency within other databases, we mostly talk about business-related concurrency. So that means, let's give you an example. There is one customer, ID 20, last name Doe, first name John. On user 1 changes the last name. And by the way, this is one of the most famous example of concurrency. User 1 changes last name, Doe to Baker, for example, and user 2 changes the first name from John to Mike. User 1 stores the customer, user 2 stores the customer. The result at the end will look like this. 20 stays the same, for sure, Doe, Mike. Why is that? The reason for that is we always storing data row-wise, I would say. So whenever you call a store method or an update method on a database, you always store the complete whole row. That means user 2 does not recognize the change of user 1 from Doe to Baker, and it rewrites Baker with the already existing Mike, I say. Is that right? Doe to Baker, and yeah, and user 2 does not recognize the change, and it rewrites or overrides the change of user 1. So that's, yeah, a famous example. And mostly this is handled by most of the databases by providing locking mechanisms, right? So, and also Hibernate has its functionality like the optimistic strategy, for example. That means each row has its has a flag changed at or something like that. So there are some mechanisms built in the database. Mostly it's a lock, but it's a really how to say a really old and not performance solution locking things. And on the other side, the optimistic lock is an okay strategy, I would say. Yeah, we have to find, but there is some more not that famous example. Let's imagine we have a car selling company, and the rule is that only one car should have a 20% discount at a time or at a day. So and the user 1 calls the get discounted car method, and it gets the result of car 1, right? So that's okay. And there is a second user which calls also the get discounted car method, and user 2 gets the same result, car 1. Now user 2 calls the set discount car on the car 2. That means car 2 is discounted, and user 2 sets a second car as discounted. And both of the user remove the discount from car 1. The result at the end is now we have 2 cars which are discounted at this day. So that means what I want to say at this time is the database itself is not responsible for handling business-related concurrency issues. So because there are 1,000 different possibilities to get in trouble with concurrency, and that's why every developer should be aware of handling concurrency within the Java code, because the database itself could only cover, I would say, some of the most famous situations, but not all of them. But these 2 examples here are, I would say, these are business-related concurrencies. And that means you have to deal with that business-related concurrency also with, it doesn't matter if you use EclipseStore or if you use MySQL. You have to deal with it no matter what kind of database is at the end. We already talked about this, so that means I want to skip this a little bit. We talked about this, but that's it. That's okay. Okay, so when we search for concurrency, we will find thousands of different solutions. So you could search through the internet and try to find something about concurrency and how to handle it, and you will find thousands of different links and pages and something. And this is what I want to do. I want to give you an idea how to handle concurrencies and especially the technical concurrencies step by step. So step 1, what you always have to consider is when you one possibility to deal with concurrency is to prevent concurrent accesses. This is also what most of the home pages are recommend. Try to prevent concurrent accesses whenever you can, because it doesn't matter what kind of technology you use to handle concurrent accesses, it will always slow down the performance. Always. There is no way to prevent or handling concurrency without having any performance issues, for example. So that means whenever you can, try to prevent concurrent accesses whenever you can. But how could this be possible? The first one is try to use immutable objects whenever you can. That means this is one solution. So using the new upcoming technologies within Java, the Java records. The Java records provides immutable objects by default. So that means every object which is created or every instance is an immutable instance. And based on that, you will not be able to change any attribute of an existing person. Now you might say, okay, this makes sense for some of the elements, but not for every element. And yes, you are right. So when you search for records and you search through some advices using records, most of them will recommend you to use records for specific type of objects, but not for every object. And on the other side, you could use the private final field. That's an immutable option on the field layer, I would say. So that final modifier makes the field immutable. That could also be helpful at the end. The reason or the big advantage is you will not be able to change a field at the end, and that leads to you always have to delete the existing person and you have to create a new one. And this prevents you by default doing concurrent things on one object, because you have to delete the first person and you have to create a second one. And that prevents you from working on one person in two different threads. And that's what it means when I'm talking about prevent concurrent access. And you could do this with a record or with the final keyword within Java. Let's jump into the project. How does it look like when we do this within Java? And you might be surprised because it's quite easy to understand when to use final and when not. So it's in a lot of times it's just a business question. So let's jump to the next one. Switch to. Let's start with this one. So when we now look at the domain classes, this is the record. I already explained that. It's red marked because I used the wrong JDK, but this is how the records look like. We already talked about this, but let's have a look to the book itself. And now let's talk about which attribute could be a final attribute at the end. For example, here, when we created a book, let's say whatever book, it doesn't matter. So is it possible to change the ISBN number of a book? Is it possible in the real world to change an ISBN number of a book? And you would say, no, we are not able to change the ISBN of a book. So that means let's make it final. So because we are not able to change the ISBN of a specific book. Next question, what about the name? We are not able to change the name of a book. Once a name is given to a specific book, this will never change. Except an English version of a book or something. It's the same on the release date. As soon as the book is released, it's not changeable. The release date is set forever, I would say. What about the price? Yeah, sometimes the price could be changeable. And yeah, let's keep it as it is. And what about the author itself? It's the same on the author. So that means the author could not be changed. It makes sense having it the final way. Now you might say, okay, oh, what a shame. So all the fields are final, but what about the price? If the price is also final or would be final, then we could use a record instead for a book instead of using that final modifiers all the time. That's true. But for that reason, we could remove the price and add it to a different table or object to have the price separated from the object itself. And that leads you to a better object structure and to an immutable object structure, to have that. So I would say, give it a try. You have to see the business side of an object and use final modifier whenever you can, or you use records whenever you can, and that minimizes the possibility to getting a concurrent access situation, which leads to an exception at the end. So using final or using records is strongly recommended from my side. Next step would be, we already talked, or we already see that, using synchronized. Using synchronized not only on so need to find the right point here. So yeah, we could do this way. So that means we could try to add. So you see that there is one method within our data access object. I created a data access layer, I would call it, and it enables us to say, okay, public synchronize. So that means with that keyword, only one thread is able to use that method at a time. That could help a lot. But based on that synchronized, there are many disadvantages, and it will slow down your performance. But this is what I already explained. Whenever you try to prevent concurrent accesses, you will have a lack of performance at the end. But good news is, when we're talking about working with EclipseStore and with an in-memory technologies, the accesses to the data is X times faster than any other data access that you dealt with before with a relational database, for example. And that leads to a situation where those synchronized methods are no longer that important because the accesses are that fast. You will never notice that because, yeah, it's a really fast technology. And in a lot of cases, synchronized will not be that, or will not influences your performance that much, I would say. Okay, there is another method using synchronized. You will be able doing it this way. This is also possible. You see that? You will be able to create a synchronized collection, for example. This could also be possible. In some cases, it makes sense using this, especially when you use collections that are not that high frequented. It makes sense using a synchronized list that synchronized everything, reads and writes on that collection, and prevents you from that exceptions. Most of the time, and to be honest, in a lot of projects, we do not use any synchronized stuff on collections because, as I said, it synchronized also the reads from the writes and so on. We didn't get any problems so far. So we are talking about 1,000 concurrent users on an application server, and this is working like a charm, I would say, because the accesses to the collections based on that in-memory database are that fast you won't get any problems. There are some huge collections, I would say, and then it makes sense to have a synchronization or a concurrency handling at the end, but not on the low frequent collection. This is not necessary. Okay, these are the two basic steps, I would say. Synchronized might be a possibility, and creating immutable objects, that's the important ones. Let's move on to the next step. Reentrant read-write lock. And this is my personal favorite, I would say. Whenever we have to deal with concurrency with EclipseStore, I used that reentrant read-write lock. There are a lot of advantages compared to the synchronized, because the reentrant read-write lock differs between read and write locks. And I will show you an example based on that. Because the usage of synchronized is more rigid and it's tied to the code structure, which is not the case on the reentrant read-write lock. Yeah, I already explained that it's tied to the block structure. And the reentrant lock has we call it a fair mode, which means that threads that are waiting in a specific order, the order stays the same. So the reentrant read-write lock works like the first in, first out order. And this is not the case on synchronized. Synchronized is kind of like a random access, stuff like that. So, okay, let's jump into the example, how to use the reentrant read-write lock. It's on the step 2, reentrant read-write. Let me discard this. And I created one example. So there is, so you could use these two classes or these two interfaces and one class. This is the reentrant read-write lock. It's a default implementation what we provide you. So you just take it as it is, add it to your project. Of course, you have to understand what happened here. But you see, there is a read, there is a write, and it takes care about differ the reads from the write and so on. And let's see how it works. You will also need these two interfaces. Just copy this to your project. And when we go to the, let me see, where are my, no, it's not there. Book controller, no. Just a second. I'm missing the DAO book. Huh? Am I in the right branch? Let me just check. Team. Okay, here we are. This is the right branch. It's the branch number 3, isn't it? Number 2, step 2, reentrant read-write. Okay, this is the right one. So, but it's the same. Here are these 3 classes. There is one data access object, which is I'm used to call it DAO for data access object. You might use a different type of structure, but it's totally up to you. And you have to extend this from read-write blocked. And that's the class we copied in. And after that, you are able to use a mechanism like this. Just whenever you write something, for example, you add a book or you clear a book, or whenever it is a write request, just use this type of code, this write access. And that means everything, this write is yeah, like I said, it's locked from all the other reads and so on. And this works really great. Just give it a try. For me, it's my personal favorite, and we can try it. So that means let's start that application. I just have to check if there is already a storage there. Refresh. Here there is. It's data. Let's start it. Let's do a Maven update. Application run as. Okay. So let's do it like this. So let's say create. Books are created. Is there a, or let's iterate. Yeah, create, and let's say iterate. You see, books are iterating all the time. And then we need the delete book. So, and now you see, we are able to click in a really high frequent way. There are no problems anymore. So, and you see how fast this is working. Yeah, I don't know. I deleted thousands of books now. So because you see, this is working really great. And my personal favorite, the re-entrant read-write log. Okay. Let's move on. Step number 3, usage of concurrent collection. To be honest, most of the concurrent collection working okay, I would say. There is a concurrent hash map, and they are not working not working, how to say that, not entirely good. They are, especially some of them are quite slow, and there are other problems with that collection. I'm not an expert on this, but I evaluated this some years ago, and each of that collection has its pros and cons, and maybe that works good for you using a concurrent hash map, for example. There is another one which is called copy on write array list, for example. There are many different implementation of concurrent collections, and yeah, example, the copy on write array list. Yeah, this is okay for medium-sized collections, I would say. Then it's working. Then it is working okay, but it's not the fastest one. So I would recommend you to use the concurrent read-write log, or using final or synchronized before. It makes more sense than. And yes, sometimes also these concurrent collections could help. And that's it. I think this is all about concurrency. There is the same. Let me just check in the application itself. I prepared also an example based on a concurrent collection. So team switch to a concurrent hash map. Let's jump in. This is the data root. Here we are. You see that? So I created a concurrent hash map here with string books, and this is also working. It's not that fast like all the other solutions, and there are some. It's not entirely thread safe. There is a small part within that hash map that is not synchronized, and that sometimes that leads to a problem. But if it fits good for you, you could use it. Okay, so we could also start this. This will also work. You see, there are many steps you could go to handle concurrencies within your data structure. It is like it is. I would say it is one of the biggest disadvantages of EclipseStore. But you will get an insane amount of performance out of that in-memory technology. And yeah, it's the trade-off, I would say. That's what you have to deal with at the end. But to be honest, it's not that important handle this perfectly all the time. So we are doing a lot of projects that are working for years now, and no concurrency handling is in it. You have to check are there any collections which are highly frequented accesses by many concurrent users? Then you should do something. But all the low frequented stuff, you don't have to deal with. So yeah, that's my recommendation. Any questions so far? There was one question regarding concurrent collections in Java. Better than synchronized? It depends on the collection, I would say. I would prefer synchronized more than using a concurrent collection. Give it a try. Try to stream through a concurrent collection, or try to use JMeter, for example, to access multiple threads to one collection. Give it a try what happened at the end and how many requests you could get or responses you could get per second using a concurrent collection or using a synchronized instead. It depends on the data structure. It depends on how big are the objects. It depends on how heavyweight the changes are and so on. It's hard to say. Both technologies are valid technologies to handle concurrencies. Yeah, it's related to the situation, I would say. Okay, that's important. You have to know this because all users and all threads are working on one object model. Okay, let's move on to the next topic. Before I jump into the where are my topics? Couldn't find them. Type handler, concurrency. We talked about that. Just a second. So. Customization. Next topic for today. I already explained that a little bit when we talked about the topics at the beginning. And there are three different or three main customizer within EclipseStore. There is one which is a custom class loader. That is an important one because some of the technologies on the market want to implement their own class loaders. For example, a Spring has its own class loader, right? So, and sometimes that leads to an error, especially. So the problem is that when we storing elements to EclipseStore, we always storing the full class path for mapping. And that could lead to a problem with different class loaders. And therefore, sometimes it makes sense to enable different class loaders. A custom storing behavior, this is also interesting. So I will give you an example later on, and a custom type handler. Let's talk about the custom class loader. Spring Boot, for example, has its own class loader. And some other application servers also using different class loaders, for example, the Whitefly. And this makes it possible to add your own class loader. And there is one example we provide here. It might be possible that, especially with Spring and so on, because of the Spring integration of EclipseStore, there is no change of the class loader necessary. But it looks like this. Whenever you want to set this, there are when you get a very strange error message within EclipseStore, that means he couldn't find a specific object after storing it, and then you will get an access that looks like you couldn't find a specific object. Then mostly it's related to a different class loader, and it's sometimes this could help. it might be possible that is no longer required with newer versions of EclipseStore, but I knew this in the past. This was sometimes necessary to change it. And I also prepared an object or a project for you. Custom class loader. Let me share this. Just a second. So this is the project, custom class loader. It's the same type of code. I just used the main start. I think the embedded storage foundation, on connection foundation, we are able to set the class loader and set class loader provider. This is the method. You will also find this within the documentation. That could help. Not the important ones customizer, but it's there. It could be used. So whenever you need it, try it out. So okay, let's move on. Custom class loader, custom storing behavior. This is also an interesting one, especially when it becomes to the situation where we want to store third-party objects. I would always recommend not storing third-party objects because you will never know when other third parties changing stuff within the object itself, and that could lead to a big problem. Most of the time this will work. So because EclipseStore supports most of the Java objects, and if the object itself is okay and there are nothing special, no special types in it, you will be able to store this. But for example, what happened when the third-party provider changes let's say the class path of that object? I give you an idea. When we have a look to the persistence type dictionary, so this is the type dictionary of existing storage, and you see every object has a specific type ID and the class path here, and that's a big problem. So when you store something, it looks like this. So this is my object. I created the author object, and this is the class path, 1.microstream.domain.author. And now when you store a third-party object, then you will have the class path of that third-party framework within your storage. And now you create or you use another version of that framework, and they change the class path, for example. This will lead to an exception on storage startup. And by the way, this is also the same when you delete the author, for example. When you delete the author class, and you have to using mechanisms to be able to deleting something, because EclipseStore or MicroStream is no longer able to find that object within the storage. And yeah, it's kind of like mapping is failing, or it couldn't be parsed anymore. And that's why I would not recommend storing third-party. But instead of using the third-party object, you could use a custom company storer, for example, to prevent specific elements from storing. And this is the situation here. There is a persistence field evaluator, and that enables you to say, okay, whenever a company class is stored and it contains a field for type array, for example, it's just an example, then return false. That means this field will not be stored at the end. It's kind of like the same using a transient annotation. This will also work in that case, but there are many other different possibilities. And it's important just for you to know that with that company storer, you will be able to provide a different storing behavior. There is a second situation here. For example, whenever you use an eager storing, you could tell them when this specific class gets stored. Let me just double check if I understand it. Custom eager storer. Okay. So that means every field which is annotated with the store eager annotation will be stored anyway. So there are some more examples within our documentation that might. So to be honest, I never used this at all, but sometimes it makes sense in special situations that could help you to improve the storing behavior. For me, I couldn't find a situation where to use this exactly, but yeah, it's there. You have to know this, and that provides you the possibility to do customization on storing things. Let me share the project. It's custom storing behavior. Let's jump into it. Maybe I choose the different situation that is more. So I have a company. Yeah, you see that whenever you with that store eager annotation, whenever a customer is stored with a lazy storer, you enables with that annotation that this company is stored all the time, no matter if we use a lazy storer on the customer itself. So that helps you, yeah, if you want to say the company should be stored all the time, no matter what storer we are using on the customer itself. So this is the annotation. This is the custom eager storer. And it works like this. There is more explanation how to use this API within the documentation. For now, I think it's important that you know that there are some possibilities doing that, and that's enough. Okay, let's move on. And the next customizer, and in my opinion, it's the most important one. It's the custom type handler. So the custom type handler helps you to keeping the amount of RAM and of references in an acceptable range, I would say, and getting much better performance by avoiding references in the storage or on disk. For example, there is one example object here. It is called a class called timeslot, and it contains a local datetime from and a local datetime to. And the problem on local datetime is local datetime consists of many different references to other objects. And for example, when we want to store many of those timeslot elements, you need more RAM for the object itself than for the data. So, and in that case, it makes more sense using a long value, for example, instead of using local datetime. And this is managed by the custom type handler. You see that this is what I explained, the references, and there are thousands more. And it looks like this. So custom type handler. Here we are. Moment. Type. Custom type handler. This is the project for you. Just to have an example for later usages. Custom type handler. So this is the time slot element we talked about. So the time slot class we talked about. And this is the binary type handler here. Type handlers or custom type handlers are always part of the class itself. And you have to add a handle type method down here. You implement a handle type method, and it's just like a mapping. So the integer field stays the same. So it's a primitive integer, primitive int. It stays like it is, nothing special here. But especially from the slot from, we converted. This is I always have to find the right slot from to epoch millet. This is the way that goes to the database, and this is the side when the data is loaded from the database. So the conversion is made there, and this is kind of like a mapping for your class, and that increases the performance enormous, especially when it comes to the situation where we want to store millions of time slot elements. Then you have to calculate how many reference or how expensive is a reference itself, and this gives you the possibility to, I say, storing X times more elements than using instant by using a long, for example. It's always a best solution whenever you can, using primitive types, then because primitive types are always much more cheaper than normal Java reference objects, I would say. Okay, this is a great solution. I used this often in the past, especially when we have to store millions of objects within our RAM. That helps a lot, and this also keeps up the performance enormous. One example, just try it out. Whenever you see, okay, something went wrong and you could improve your performance, and if you do not really know how to handle this, just send us an email, and we support you to find the right type handler to store them. Okay, there is another customizer which is called the custom legacy type handler. It's the fourth one, but let's jump into this type handler for a short second. You will find all the customizers here, and this is the legacy type handler. This type handler handles how to explain that when a type changes. So this type handler is made for special type handling. That means whenever your storage structure changes or when different types are changing. I never used this before. It's there. It's nice to know. Give it a try. Just read what it does or what it is made for. But it's not worth for now. Maybe it is used in some project. I don't know. I never used it. Okay, these are the customizers. There are one last topic. I want to go into it. It is the cloud solution, and therefore let me just jump into not the last topic for the day, but so there we are. Where's my presentation? This is the current. Yeah, here we are. Okay, so too many screens. Okay, so it's a part of my JCon presentation. I don't know if you visited the JCon 24 in Cologne. I had a talk there creating scalable Java applications, microservices with EclipseStore. This is a talk which is specially made for talking about replication, how to handle that, and not only talking about EclipseStore for replication, also talking about replication itself, and what are the main topics on replication. So let's go through. So what is EclipseStore? I think we could skip this. We already talked about the technology, and we always get asked by our customers, what about scaling? So, and we first have to clarify what scaling means. And it's the same on our customer side. Most of them are asking for scaling. And when we dig a little bit deeper into that question, we mostly see, okay, scaling is not really a topic, and yeah, let's find a solution for our customers. Okay, when we started to evaluate the scaling topic, we had to deal with a lot of different terms. So some different states and type of replication, consistency. We see async and synchronous replication, and many different words and findings. And we analyzed that there are two things at the beginning, the most important ones. Do we talk about horizontal or vertical scaling? That's the first one. And we always have to clarify scaling for what reason. So do we talk about data scaling or high availability or fail-safe? And these are the only three important topics at this point. But first we have to clarify what is the difference between horizontal versus vertical scaling. Okay, so vertical scaling means increasing CPU and RAM up to a certain limit. And this is quite funny because when we talk about scaling, most of you might say, okay, vertical scaling, it's an old technology. Nobody wants to do that. We have Kubernetes, we have Docker, and so on. Let's use this. This is a much better solution for scaling because it's limitless, I would say. The truth is, do you know the biggest EC2 instance that you can get from AWS for the moment? I'm not exactly sure, but it's, I don't know how many cores. I guess 256 cores and something about 400 terabytes of RAM, stuff like that. And it's insane. So the biggest yeah, okay. So, but yeah, the problem is, or the point is, most of the time, in my opinion, I would suggest to use vertical scaling at the beginning, and you would be surprised how far you could scale just vertically. But let's move on. The pro side, easy scaling, no big issues. It's cheaper at the end for sure. And many people would argument and would say, okay, but vertical scaling does not provide high availability. But to be honest, the truth is that AWS guarantees 99.99% availability for now, based on the infrastructure. I would say, okay, what could go wrong? But it's always, there are always some projects, they are really important. Then you need to scale. And okay, for that project, it's expensive and it should be, it's highly complex. And to be honest, vertical scaling is technical. There is a limitation, and high availability is not covered at this point. But a funny thing is, you might wondering how many cloud solutions are providing replication and scaling, and at the end they are running on a big EC2 machine with Docker or Kubernetes on that one EC2 machine. And then at the end, you don't have, this is kind of like a fake replication or a fake scaling. And that's a real problem. But based on that, let's move on to the horizontal scaling. It's increasing the number of hardware units within a structure. For example, container within Docker or node within Kubernetes. There are no limitation for scaling. It's high availability is solved, I would say, with that solution. On the con side, we have a costly infrastructure and staff costs, and it's highly complex. Okay, but the basic terms, vertical scaling versus horizontal scaling, we knew what it is. So then we have to talk about data scaling. For what reason? So mostly we're talking about data scaling when we want to increasing the amount of data. So that means we want to have limitless capacity of storing data or distributing data across several smaller databases, for example. Then we're talking about sharding, and that provides us the possibility to increase and increase and increase the amount of data which is within my database. It looks like this. And this is not the only solution. This is also interesting. Some people might always say this is sharding. I know that, but there is a second situation which is also called sharding. This is when let's imagine we have one database like what we do now. We have books and authors and maybe orders of books or stuff like that. And in the interesting part, I always said, why not to create smaller nodes or smaller data provider, which only provides company data, for example. Another node provides customer data. Another node provides order data, for example. That means each business object has its own data provider. So that means 3 machines with EclipseStore in it as a storage technology could provide different parts of the database. That means there is no one big monolithic app that provides the data. There are many smaller that brings you much more scalable systems at the end. And if one pod is failing, for example, not all the pods are failing, you know. So there is always some pods they are running. So and that's a big advantage. This is also called sharding. It's not only sharding one specific type. And there is another one which is called the replication itself, a high availability or fail-safe. Fail-safe means, by the way, not failing anymore. Fail-safe means keep the impact as small as possible if something failed. So keeping response times within an acceptable limit, whatever happens to the system, if some instances are failing, or if you have an increasing or abnormal amount of concurrent accesses, for example. And it looks like this most of the time. So that means we have to replicate the data or to create copies of the same objects to different replication. And there is one load balancer in front of those systems that routes you to the right node, which provides the data at the end. When we talk about replication, we have also to clarify what means stateful versus stateless, because this is an important topic when we have to make the decision if it's highly complex or not to scaling systems. So that means when we talk about stateful servers, it doesn't matter how big the server is. Give me just a second. Okay, so when we talk about stateless, that means that's an easy node replication. Let's imagine there is one task, let's call it microservice, whatever, and this is running somewhere. So we will be able to replicate that service 1,000 times, right? So because there is no state within that server, and that means whenever someone needs to create a report, the server wakes up or the replicated stuff wakes up and provides the report at the end. This is stateless replication. It's the easiest way to replicate those, nothing special to do. And it becomes to the hard mode, I would say, when we talk about stateful data replication. And that's mostly the case when we talk about databases. So then we have to deal with replication and a lot of highly complex things that we need to deal with. So that means stateful is the hard way, stateless, easy way. So then there are some more decisions within the replication. So what type of replication? An async replication, for example. That means the request comes in. This is point number one. And on step 2, you will get the response instantly. That means the replication itself, it's happened in the background, but you will get the result quite fast. Writes are, we would call it non-blocking. So that means you will get the response instantly, and the writes are the replication happened in the background. And there is another one, we call it synchronous. Then the writes are blocking. You see that the request comes, then we do the replication, and at the end we will get the response. That's are the differences between async and synchronous replication. Last but not least, there are a different architecture: single leader architecture, multi-leader, and no leader architecture. Surprisingly, most of that different architectures are tied to a specific use case. That means a single leader architecture is, I would say, the most common replication we see on the market. It's a single writer replication. Means the writer provides the data to the different reader nodes. It's on most or on many homepages known as the best possible combination of performance and strong consistency or no stale data. And yeah, as I said, most common replication, easy one, I would say. And it's not tied to a specific use case. The next one, multi-leader, for example, it's mostly used on data center replication. And there are two different versions of that. One is the cross data center request. We see that here. And yeah, as I said, mostly this is tied to data center replication. And it's use cased offline mode, for example. So this is a good example. Most of the people are or do not understand when to use multi-leader, for example, but every one of us is using multi-leader, especially when we use an offline mode, for example, for Google Maps, for example, when we create an offline snapshot of a specific map, then this is also called a multi-leader replication, because the data has to be replicated also to your offline stuff and so on. There is an eventual consistency running. This is also another point, eventual consistency or strong consistency. You see there are many different aspects on data replication we have to talk about. For example, strong consistency means high latency but no stale data, compared to eventual consistency, low latency versus possible stale data. That means many decisions has to be made when it comes to data replication. And we didn't talk about infrastructure, backups, monitoring, logging, and so on. There are many other stuff which is working. And based on that, we decide to create, sorry, I'm too fast. So we decide to create a cluster solution with the following specification. So an asynchronous replication on a single leader cluster with an eventual consistency. So that provides failover, high availability, no data loss, or no data inconsistency. This is what we provide within our cluster. Okay, the question is, let me skip this. This is not really interesting. This is the architecture which has happened in our cluster itself. So we have the clients up here. There is one load balancer, and there are some more servers here or some services here. It's not only the main load balancer. There is a writer proxy, we call it. This makes the decisions to forward the read, for example. If a read request comes in, the writer proxy decides which reader node is responsible for this, but write requests will only go to the writer node and it will be stored to the storage on the writer node, and then there is a replication ongoing in the background that spreads the data to the different reader nodes. This is how it basically works. We use Terraform and Helm for that to set up the cluster. So whenever you click within our cloud system, you click on Create Cluster. We're using Terraform and Helm at the end. It configures the cluster, and the biggest question was for us when we start thinking about creating a replication. We knew that EclipseStore is still a framework. So it's not a server, it's just a framework that works. And we thought about, okay, so let's imagine building a server on top of EclipseStore could make sense, right? So just adding a piece of code somewhere and starting up the server, and for example, a Micronaut application. And when we compare both situations, a relational database compared to a Micronaut application, it's mostly the same in a specific way. So when we talk about a relational database, we have to install the database or use one as a service. We have to create tables and constraints. We have to create a JDBC connection, define queries within our application, and we have to call the query. And it's the same on the Micronaut side. So let's say we're creating our own data provider, what we, by the way, did in the training all the time. So we created Micronaut services that provides data via REST, which is stored at the end with EclipseStore. And that is the same on the database side. It's kind of like creating your own database. So you have to set up a Micronaut project. You have to create a data structure in Java. It's the same like creating tables in a database. You have to create REST interfaces, and it's the same by creating a JDBC connection or defining queries in your application. On the other side, you have to create REST interfaces, and then you have to request those interfaces at the end. And to compare these two systems leads you that we are able to create our own database with just a small amount of very good standardized things. So we have standardized microservice frameworks like Spring, Micronaut, Helidon, and so on. We have EclipseStore itself that's handled by us, so easy thing. It's the same on the cluster side. And then we have REST, which is also quite good standardized. And based on that, the idea is a central point for hosting an application. And this is working like, AWS Lambda. This is kind of like the same, especially for EclipseStore. That means we're providing you a system where you can upload your application, your Micronaut application, for example, and we're doing all the replication stuff in the background. And you do not have to do anything. How does this look like? So let me share this with you. So where we are. So, okay, this is the cluster. So this is our cluster, our cloud platform for now. So when you register there, you will see this with some news and support and create your account, getting started, and so on. This is, by the way, also the certification part. When you register there and you register with the right email address, at the end you will see your certificate here. You just click on that button, and then you will see your certificate upcoming on the right, and then you can download it or whatever. But let's come back to the platform. So the first thing you have to do is you have to create a platform itself. Because we're providing a fully Kubernetes environment. And this is what happened here. So this is on the AWS side, we're creating an EKS for you. That means you could create a platform, you could choose different platform providers and different regions. For now, we support, so I already have a Frankfurt one, but I could create an Ireland one or Asian Pacific, whatever. So you make the decision, what platform do you want to use? And there is a platform already available, and within that platform now you will be able to create multiple different clusters. So that means just click on a cluster, and then you could make decisions on the first step. Okay, what kind of cluster do we need? Let's choose a small one. That means the minimum amount of nodes is 1, of course, and the maximum amount of nodes is 2. That's for the small. And it's different for the medium size. When you say, okay, we need 5 or 10 working nodes at the end, you could choose this here. Because the infrastructure in the background is more, let's say, more powerful, I would say, or based on with the base tier. So let's choose the small. Then you have to make the decision. Do we need small nodes with a different specification of the gigabytes and RAM and CPUs? And it's also different when you choose medium. You get a wider range of CPU and memory at the end. And when we say, okay, minimum 1, maximum 5, you could have 5 nodes with 2 cores and 16 gigabytes of RAM, for example. So let's choose the smallest one. An interesting point is we provide a dynamic scaling system. That means when you say, okay, let's say I want to have a medium one, a minimum is 1, maximum 5. And you could say, okay, let's choose medium. Then you could say, okay, minimum is 1 or 2 maybe, maximum 5, and you will only be charged for the real usage you have at the end. So if your application scales because you have many concurrent users or accesses, then the cluster will also scale till 5, and you will be charged for 5 for that specific time frame you need it. And if your traffic goes down, it goes down to 2 at the end. Okay, but let's choose the small one. We only need 1 and 2. Let's click next. This is the part where you provide a name, for example, an application type, let's say Micronaut application. And then you could add a specific repository URL. So that is mostly the repository URL of your project. And I provide I have one project, which is within my GitHub. Let me just share this with you. One moment. Where is it? Is it this one? Just a demo. Yeah, it might be this one. So just have a look here. This is one project, and it's the same type of project we worked all the time. So it's a Micronaut project, and it consists of main method, a storage, a DB class, data root, all that stuff we already knew. And the only difference from a controller class and so on, so you could put everything of your code within that application. The only thing you have to take care about is using the right storage manager. Let me just double check this. Resources. There is an application YAML. Cluster demo. I'm not able to share this with you now. Need to find it. Give me just a second. So where is the... I'm afraid it is used directly in the cluster itself. So could not share this with you. So the point is we are using a different storage manager within those projects, and that specific, it's a cluster replication storage manager, and it enables the automatic replication in the background. And this storage manager is different to the normal ones. And you will be able to upload that project at the end here on that repository URL. You could make some decisions to creating backups once a day, 3 times a week, whatever. It's totally up to you. You could use an AWS private link, for example, and some more adjustments, different proxy settings. This gives you the possibility to make the decision. What is the criteria to send requests to different nodes? For example, in this case, we say, okay, all the put, post, delete, patch goes to the writer node, all the others goes to reader nodes, for example. There is another possibility to adding a specific URL path, for example. That means all the requests with a specific URL path goes to the writer. And it's the same routing via a header value. That means when you add a specific header value, this request goes to the writer node instead to the reader. We are able to upload a storage at the end, and then it looks like this. There is an already existing cluster because it needs a little bit to start it and to make it happen. And at the moment, it's so you could click on details here, and then you will see what's going on the cluster. You see these are the nodes. They are quite bored for now. Nothing is ongoing on that cluster. You see this is the writer proxy, and that is another proxy which is working. And sometimes it's interesting to see what's going on that system. You see down here some configuration stuff you could do, changing backup configuration. You have all the stuff in place to see what's going on my cluster. You see how the cluster is working, the different proxies and so on. And there is another point, seeing all the logs of the server, and especially all the logs from the different nodes. So let's choose these 3 nodes, and you see all the upcoming logs within the cluster to try to find something. If something goes wrong, that gives you the possibility to see what happened there and so on. At the end, let's move back. The cluster is up and running. Let's give it a short try. I've prepared. This is the Postman. So I prepared this. You see, we could add something. Just call it, and when we see the list, it's the same URL. At the end, you will get the URL here, cluster URL. You can copy this, and then you can access the cluster at the end. And I added the URL here, and you see the data. I added it 3 times, and the data is there. It's just the data provider we used all the time before. That gives you a great functionality, because you could use your data provider normal as you are used to do. That means creating micronaut project, use it as a single standalone application. And at the time your concurrent users are growing more and more, you choose the exact same project, change the storage manager, and provide it to us to the cloud, and doing replication there. And it's working out of the box without any changes on your project itself. There are some rules you are tied on, but that's okay to handle this most of the time. So that is a possibility to create your own databases in the future that are much faster than all the other stuff on the market, I would say. Okay, so some of you might say, okay, it's a cloud service. I'm not able to use it because it's in the cloud. I would never put my data to the cloud. The good news is this solution is also available as an on-premise solution. So it's not provided as a product that we give it to you and you could use it and you could install it, because this product is or the requirements having such a system, there are that much that we provide this via as a service. So we always we deliver all the Helm charts and all the configurations you need to have to make it happen on your infrastructure. But and you will also get a backend like this to do all the administration stuff at the end, and then you could use this as an on-premise service within your company to creating replication and clustering like that. I think that's the idea behind such a cloud solution and cluster solution. And for those of you who want to test, feel free to do it, creating smaller clusters and give it a try. It works the same like a normal data provider at the end. Yeah, it is like this, pre-configured. I don't know what you mean with RSet. RSet is what means RSet? Maybe I didn't get it right. So yeah, Rechenzentrum. Okay, okay, got it. Yes, it is. It is. Yeah, it's planned like this, of course. Okay, so what are the upcoming things within the cluster? Maybe that's interesting for you. There are many different things what we want to add. Some of them are already in. So, for example, the Spring integration, it's there and it's working. There's features that are already available. Okay, we are able to upload. I think we talked about that. And the next thing is the roadmap. We still have to provide. We still have to provide Azure and Google Cloud. For now, we are providing only AWS. We are working on moving to all the other solutions. We working on deployment CI/CD Jenkins integration for providing stuff directly to the cluster. Autoscaling is already implemented for now. We released it 1 week ago, I guess, the autoscaling. So it's in already. And we are also working on different cluster types for now. There is, for now, we're providing high availability. That means no matter how many concurrent users want to access the cluster. And we are working on a big data cluster. That means more in the sharding direction for handling gigantic workloads and data throughputs. That is what we are currently working. And it's also based on EclipseStore. So a different version of EclipseStore, but it goes in a direction we talk about vector databases and so on. Yeah, you might be surprised. There is a lot of upcoming stuff in the future. Okay. That's it. I think there is one topic we missed for now. Or are there any questions so far? So a lot of stuff ongoing. Feel free to answer. I tried to doing my best to answer this. There was one question regarding OSGI. Is that answered the question so far, or to be honest, I'm not an expert in OSGI, and
OSGI is a platform, for instance, running Wildfly or the Eclipse Workbench.
yeah.
And you have a custom class loading mechanism there, or you have an
okay.
or what you can do with microservices, you can do as a monolith inside Equinox. So you have different class loading areas, and that is quite challenging.
Okay, I understand. Yeah, so then that could be a good solution for you to changing the right class loader in the right situation, I would say. Okay, so just a second. So there is one situation, or there is one topic that I skipped a little bit. It was the third one here: gracefully shut down and exception handling with Docker and Kubernetes. So in my opinion, it's quite important to know that. I skipped that a little bit because this topic is also part of the Advanced 1 training, and some of you might already heard that. for the exception handling, I could provide one example project, which is specially made for as an example for exception handling. Let me just search it or find it here. Here we are. Maybe we could also have a short look in an existing project here. It's already there. Exception handling, here we are. So that makes sense. Okay, so let's jump into the controller. So yeah, so this is what I talk about. Let me just switch the branch. Maybe there's exception handling. So switch to yeah. This looks, no, that's not the one. That's not what I want. So okay, there is no class. No, that's not. Moment. So we use the warm-up project. That should be okay. Yeah, okay, here we are. So I skipped that a little bit, but you have to deal with it, especially when it depends on the rollback mechanism. So we talked about the transactional behavior and so on, and this is how it basically works. So this is also quite important to use this because there is one special behavior within EclipseStore that could lead to a big issue when you if you not did it the right way. So let's imagine we doing stuff like that. So we have a list with something and we starting changing things within that iteration here, and something goes wrong here, or it couldn't be stored for some reasons. The problem is always you will, as a user at the end, you will never notice it that something goes wrong because data is already changed within the RAM. And even when storing the data is not working as expected, as a user, you will not notice that because it looks for you fine. The data is in the memory. You changed the collections within the memory, and application is up and running, and yeah, nothing goes wrong. As an administrator, you would see it in the logs that something goes wrong, but then maybe it's too late at the next day because people are working and working and working, and it's not stored. And when you restart the server, all the changes are gone. And that leads me to the point to show you a situation or how to handle that with a try-catch. You should always take care about those situations, and especially the reloader here brings you in a situation to roll back all the changes if something goes wrong. And there is one project, and I have to share this with you anyway. So it's called exception handling. Yeah, here it is. So this is the URL. Just check it out and find all the solutions. And there is exception handling master team switch to best practice done. It's the same here in that project, which is quite important on the DB class. So I normally use those DAO methods, and at the end we are calling a store methods, and it's the same here. We created a second, where is it, the DB class? You see that there is a second store method that we wrapped around the original ones. and we added it to a try catch. Whenever something goes wrong on the storage side, for example, it could not be stored because the persistent volume is unclaimed for whatever reason, then the application goes down. So that means on storage failure, the application will shut down and it's no longer reachable. Just to prevent this exact situation that people are still working with the application itself, everything seems to be okay, but on restart, you will lose all the changes at the end. Just check this out. It's how to do this. I'm pretty sure there are many different possibilities to implement such an exception handling, but you have to deal with that, and you have to be aware of that. I think that's the point. Okay, that's the point regarding the exception handling and transaction and rollback. And the other 2 points, shutdown, we already talked about shutdown, and the next point, and that is a big point, we had an issue few weeks, I would say. A customer calls us and say, okay, everything is crashed, the storage is not accessible anymore, and we tried to find the reason for that, and the reason was a gracefully shutdown. I think most of you are aware of gracefully shut down servers, especially on Kubernetes. But some of you might say, okay, never used this before. How is that working? We stopped the thing. And it's not only gracefully shut down, it's also using Kubernetes embedded functionality, like on the persistent volume, the copy mechanism. Please do not use such a functionality together with EclipseStore. The point is, you will never know if EclipseStore is writing something to the storage itself. Now, when you try to copy or duplicate or unclaim the persistent volume, your storage will crash. So that means this will work 100 times without any issues. But there is one situation when you remove the persistent volume, or where the shutdown is not working as expected, that will crashes your binary file. And you should always take care about never use an external functionality to create backups of a persistent volume. And as far as I know, there are some frameworks are able to notice when on Kubernetes something happens. There are some event listeners on that. Especially, I guess, Spring has their own event listeners. They react when, for example, the application is on shutdown, then it shut downs the application on the pod, for example. Please use such as a functionality to provide a gracefully shutdown at the end, and please never use third-party functionality on the volume on the binary files. This will lead to that could lead to big issues on the storage itself. Okay, that's all regarding exception handling and Docker and Kubernetes. Okay, so there are 25 minutes to go. For my side, that's all. I want to provide you all the information. If there are any questions from your side, feel free to ask now. I'm done, I would say, for today. So as I already explained, we will send you the videos and the recording of the training. We talked about the certificate. Just log in or just register on the cloud platform and get the certificate there. Okay, so no more questions so far. Then I would say thank you for joining the Advanced 2 training. I hope it was interesting for you. I hope you enjoyed it. Please let me know if there are some parts that I could improve for the training. Yeah, if there are any problems regarding EclipseStore, any issues, let me know. I just want to provide you my email address at microstream.one. So whenever something is happened, or if there are any problems, let me know. If you have some questions, sometimes I have to forward your email to our developers, and there is also a support on GitHub discussions. So if there are any issues, let us know. Then we could help you. Yeah. Based on that, I would say enjoy EclipseStream. Thank you for joining the training. I wish you a nice week, and hopefully see you somewhere. And yeah, that's it. Thank you. Enjoy.